This tutorial shows you how to conduct a point-biserial correlation in SPSS. The point-biserial correlation is used for correlating a variable on the interval or ratio level and another being dichotomous, meaning it has only two values. To conduct the point-biserial correlation, go to Analyze, Correlate, Bivariate. I will correlate weight in kilograms, which is on a ratio scale, with gender, which has only two values in my example. If you wish, you can request means and standard deviations for the variables under the Options button. If you need the covariance, you can check cross-product deviations and covariances. In regard to missing values, you have the choice of pairwise or listwise exclusion. The latter only comes into effect if you correlate more than two variables. Listwise means that rows with any missing values are removed entirely from calculations. Depending on the analysis you run, this can be useful. Bootstrapping and confidence intervals are usually not required, but can be requested under the respective buttons. The Pearson correlation coefficient is already pre-selected, and what we need, since the point-biserial correlation is simply the special case of the Pearson product moment correlation. If you have formulated one-sided hypotheses, you can request the corresponding one-tailed significance testing below. Finally, the Flag Significant Correlations option is ticked, which will help identifying low enough p-values, especially in larger tables. Since the correlation table is symmetric, you can request only the lower triangle by ticking the box and also remove the diagonal. Those are all relevant options, and you can request the results by clicking OK. I'll skip the descriptive statistics, they speak for themselves. The correlation table below shows the requested point-biserial correlation. Generally speaking, focus on the p-value first. If it is below the predefined threshold, for example 0.05, the null hypothesis can be rejected. Reminder, the null hypothesis assumes no correlation, neither positive nor negative between your two variables. I can observe a p-value of smaller 0.001 and can therefore reject the null hypothesis for weight and gender. The correlation coefficient for this pair is negative with -0.533. Showing a negative association. What does that mean, since gender only has two values? A higher value of gender is associated with a lower weight in kilograms, or the other way around. For the correct interpretation, I only need to know what value is attributed with which gender in my case. I can easily look that up if I forgot. Either I have the value labels specified, if not, see the linked video, or I can look it up in the codebook. In my case, male is coded with 0 and female is coded with 1. Since I can observe a lower weight being associated with the higher value of gender, which is female, I can conclude that for this example, female participants have a lower weight. This is reasonable because usually females are less tall and therefore also weigh less. As with all correlation analysis, keep in mind though that correlation does not imply causation. Furthermore, a small p-value does not tell you about the magnitude of the correlation, aka effect. The magnitude of the correlation is the correlation coefficient itself. Compare it with existing studies or use research field-specific thresholds to classify your correlation. If neither exists, you can fall back to Cohen 92, a power primer, and use the thresholds on page 157, 0.1, 0.3 and 0.5 for small, medium and large effect sizes. My correlation of 0.533 is just above the threshold of 0.5, making it a large effect according to Cohen.